we now move to the scientific framework. What does research tell us about the future of our coasts and seas? And where can technology really make a difference? Professor Nadia Pinardi, Director of Center for Coastal Resilience of Emilia-Romagna Region and University of Bologna.
Thank you. Good morning. So, after such beautiful introductions, first of all, let me thank Assessore Colla for having given so much support to build this wonderful enterprise here in Tecnopolo, Bologna. And let's see how much we can take advantage of it in the future years. This is a real opportunity. And I will bring you back another opportunity that the region, Emilia-Romagna region, has given us is to insert our experience in Emilia-Romagna in the world through this small center that takes care of connecting your work to the world. Yeah. So I will try to show you 3 points. The first is linking the blue economy and coastal resilience, because I think this is an innovative, is a site for innovation, but is also a very important point for us. The UN Decade of Ocean Sciences, we are in the middle of it. This is a very important activity of the world in terms of innovation in oceanography, making for the first time a clear connection between science and engineering, and the status of knowledge of the global coastal ocean. I'll try to show you. The last mile, the AI solutions that we have developed here in Emilia-Romagna. So the OECD has told us the ocean economy, what will be in 2030. And this is my points out of it. First is what makes the ocean economy different from land-based economy. And I've taken only 6 points out of the 12 that they give. The first is that the sea is much larger than the land. So the problem of management of the sea is a totally different issue. And we are not well practiced on that. The second is water is less transparent than air. So all our systems from satellite need to be adequately complemented by in situ. Number 3, marine species can potentially travel much longer distances. So our resources have to be monitored in an adequate way than the terrestrial one. Nutrients and pollutants reside in the ocean much longer. We don't get rid of them so easily, so we have to be very careful. Lack of ownership and responsibility in the ocean is one important issue at international level. And 40% of the world's population live 100 kilometers from the coast. That's the population issue, which is very important to consider. So this is a figure from the report. So we're talking about, among all the different blue economy sectors, about 39% focusing on the coasts. So the coasts have a very special role to play in our innovation and in our sustainability. They're a key point. But in general, almost half of the industries work on the coast. We need to be resilient on the coast. All that infrastructure is on the coast. So, show you some more data. Coastal hazards are increasing. This is a wonderful paper in 2018 that was showing how is the 100-year sea level extreme event going to come back in 2100, let me say, sorry. So normally, now it is every 100 years. In 2100, we are getting every 10 years that same extreme event. You can see laser, can you see? No, you cannot see. You see the green around the Mediterranean, okay? Then you see also, unfortunately, the equatorial band and the tropical band with every year. So hazards are increasing. We have to become resilient. We have to find innovation that makes us more resilient. So we need to enhance coastal resilience. This is one of the major themes in the UN decade. So taking the disaster risk reduction definition, coastal resilience is the capacity of the system to bounce back to, if a perturbation arrives, which will arrive, we are capable of going back to the same efficient system or the same working system. And around coastal resilience, there are 6 different sectors: the assessment, the planning, the prevention and protection, the preparedness, the response, and the recovery. These all are part of becoming resilient. I clearly am more on the assessment and the planning, and we work together with our Emilia-Romagna region, where prevention and protection is one of the major aims for many of our public institutions and private too. So how do we achieve the goal? How do we become resilient at the coast? We need to transform the monitoring and predicting with cloud-based computing and AI, and I will try to show you some examples. This is the motto of the UN decade: the science we need for the ocean we want, and we want to become coastally resilient. So this is the program that was started in 2019 and actually officially started in 2021, will go up to 2030, this famous 2030. We have 10 decade challenges and 10 outcomes that we hope to achieve with innovation, with new transdisciplinary science. We have 50 programs, now 600 projects all around the world, and we try to interface them. So how do we do that? The Emilia-Romagna region, this is the part of the coastal resilience. And the Emilia-Romagna region allowed us to be put into this map, right? And this Tecnopolo also will allow us to bring our solutions around the world. So we have 4 centers that are coordinating centers, and this one is ours, funded by the Emilia-Romagna region at the University of Bologna. We have in France an ocean prediction, a blue economy in Barcelona, and in China, the Ocean Climate Nexus. And we work together to find the right interface between the new science that we develop with all these projects, 600 projects around the world, and the theme of coastal resilience, predictions, and so on. So just to tell you, where does the extreme sea level come from? Well, you see, this is, you find the pie, the colorful pie, orange and blue. Now, the blue is local sea level, locally forced and shaped sea level due to the coastline and so on. And the rest is from offshore. So we cannot do it without knowing the offshore. because the offshore is most of the time half, if not more. You see the North Sea is much more responsible for our extreme sea level at the coast. So we need a continuous refinement methodology from offshore to the coasts. We knew that. We started in Europe a very important initiative that is the Copernicus Marine Service. We have satellite looking from the open ocean, and we do the downscaling with the models that learn from the satellite data and the in situ data. But we cannot do different. So this is another example. The salt. The salt comes from the ocean, doesn't come from the river, right? The river is fresh water. And here we show how much the salt will arrive where we live. This is an area of savanna in Georgia, United States, where a collaboration between University of Bologna and the University Georgia Tech have developed a system that shows how much is the ingression of salt every hour, because we need to monitor that. And you see in the picture on the right, the red is the salt. Salt entering in the many channels of this very complicated area. We need to have that monitoring here too. We know that without monitoring in that continuous way from offshore to land, we are not going to solve the problem. Okay, yes, maybe, yeah. So another part that we know is that we have to be multi-hazard. We can't be looking only at the physics. We need to look at fisheries, the biology, the ecosystem. So we call it geophysical, geological, biological, ocean, weather, hydrology, climate, anthropogenic, and ecological hazards all together. That's a challenge. Also for AI, because we don't have so much data at the same time taken from geophysics to ecology. They have to be taken at the same time, right, for AI to work well. Okay, so we decided at the level of the UN decade, we had two pillars that we want to arrive to. Design people-centered, multi-hazard early warning systems. They do not exist now at the coasts. And design adaptation planning strategies to feed a sustainable ocean planning process. So planning requires data, adequate data. Okay, so the University of Bologna started a project. At the same time, we started the center, which is called Coast Predict. And this is a project that is dedicated to find science and innovation for coastal resilience. It is coordinated by a group of international scientists, but the University of Bologna also. So let's see what this project says. I'm going to run the movie now, please.
Globally, about 2 billion people live within 100 kilometers of the coast, and coasts are on the front lines of the climate crisis and other human-induced pressures. Rising sea levels, flooding, marine heat waves, extreme events, and pollution are increasing risks to the lives and livelihoods of coastal communities and the survival of coastal ecosystems. Solutions must be built with local needs at the center and be globally scalable to provide reliable tools for policymakers, managers, communities, and their economies worldwide. Coast Predict, a program of UNESCO Intergovernmental Oceanographic Commission's Global Ocean Observing System and the UN Ocean Decade, is leading a transformation in how we observe and forecast the global coastal ocean to provide science-based services and solutions for coastal resilience. At the heart of the program is the Global Coast Network. Through the global network of over 130 pilot sites involving more than 70 countries, Coast Predict is co-developing solutions in partnership with coastal stakeholders that will directly serve community needs, from risk management to climate adaptation. Coast Predict solutions integrate cost-effective sensors, satellites, cloud platforms, and AI-driven digital twins to deliver accurate, accessible, and actionable coastal predictions, multi-hazard early warning systems, and planning and visualization tools, even in regions that are currently data scarce. By combining scientific excellence with innovation, citizen science, and trusted public-private partnerships, Coast Predict is closing critical data and knowledge gaps and delivering tailored, region-ready solutions. From local to global, Coast Predict is building the knowledge and services needed to ensure resilient coastal communities, now and for the future.
Okay, so how do we work to build that system of custom-ready, region-ready solutions? So it's a complicated workflow, and we need centers like this one, Cineca and ECMWF, and working together, and others to pool enough strength. So we start from global and regional. We have done this in the past 40 years. You see my age? So I started with others 40 years ago. We said we have to start from the offshore. That's the science that told us. And we have now a very ambitious program, the Copernicus program, in Europe, and actually is a real service, which leaves open access data for everybody with a best practice and data formats established at the international level. Then we have IPCC. We know IPCC, very important, producing data for the projections. Now, this is what we are doing with Coast Predict and the DCC. We have to go local. We have to go really local where the problems are. So we thought it's a challenge for science, right? You can do downscaling, but upscaling is scientifically challenging. So now we try, because we have enough information at the large scale. So we form a network of coastal pilot sites in the world where we do innovative real-time climate observing and predicting. We consult with the local communities that tell us what are the real problems, and we solve them locally. We then intercompare globally. At the local level, we also produce decision support systems that will give this information to the local users. And then, hopefully, we will set the requirements for the whole system, okay? This is hopefully at the end of the decade. The last mile is to use cloud-based data management systems and software. We need to evolve them to be able to reach the complexity that we have in the coastal area. So this is a system that we are planning for Southeast Asia in the project. So we got together with us, the European grid infrastructure, Cineca, and other players in the field, and we are going to experiment in Southeast Asia. You see the different operators from Bangkok and Malaysia, Thailand, Malaysia, Indonesia, and the Philippines, and try to see how this different local systems can converge into best practices and standards, producing also, getting also the connection a seamless connection with external data. So data management is a key issue for AI especially. Then the second one is explore new remote sensing for the coast. For the coast, we are really at the beginning of a new era. We are now exploiting sensors that are very numerous. They're not as accurate as the others, but they can be calibrated. And then they give us the resolution that we need. We can measure only sea level at one point along the coast. We can't. So then the other part is the development of these low altitude measurement systems, platforms, balloons, air drones, and so on, that can mimic a geostationary satellite for a period of time, giving us the 1 meter, 1 minute resolution, because the actual satellites now are repeating, their repeat orbit is 3 days. How can we do with an extreme event occurring in 2 hours? So this is a wonderful example of collaboration with Rimini Blue Lab, where we put the station, the Citizen Science Station, on the Rock Island platform here, which very nicely collaborated with us and offered. And here is the level of detail that we can get with such a small interbox station that has been developed by CMCC. And here we see what we can see automatically, and this automatically is uploaded on an open source system with atmospheric pressure and sea level. And this is, on real time, an event of meteor tsunami that was detected. The 5th of October in Rimini, the sea entered without any wind. So people said, what is happening? That's a meteor tsunami, right? So here I have 3 examples of AI that we are practicing. The first one is filling clouds in satellite data, which for many of us is essential. So we have ocean color, which gives us a color fill and other suspended materials. And here is SST. We can reconstruct with AI much faster, much better. In this paper, which we are now publishing, we can show AI does much better. And we have also to transform this modeling. Let's see if I can, yes. So as I showed you in the movie, maybe I can pass over because it's already, but what we need to transform is being able in the coast to get the data from the open ocean. And now it's available through the Copernicus Open Access. But this requires us to be able, and many companies, to be able to access this data in an easy way, right? It can be done. Now is NetCDF. It's not so easy to understand what the NetCDF is and how to use it. So, but we need to do it. And here is, these are 5 models that nest one into the other until we arrive at our beautiful lagoon of Venice, or Venice Lagoon, better said. Yeah. So this system is in place. It should be reproduced everywhere. It is technology, it is innovation, and is a little bit traditional, right? Now, here is instead the real new one. This is the first system in the world at regional scales, means 3-kilometer resolution for the whole Mediterranean, that works for doing a 10-day forecast operationally. So this is the paper that was just published, and this is the error. The blue is the error of the AI for 15 days forecast. And orange is the traditional forecasting system. It's like ECMWF for the atmosphere, right? But we are talking about currents, zonal and meridional, salinity and temperature of the ocean. And let me tell you the last one. This system uses 20 seconds on one GPU for a 15 days forecast. The traditional system uses 70 minutes, 4,200 seconds, on 89 CPUs for a 10 days forecast. This is the amount, this is what AI can do. But we need to, and I was very hopeful from the talking of Sylvia, we need to finance the research that goes on the data that we collect on the models that we do in Interreg. We need to do that because it requires some development. Another one. Now here in the room, I don't see it, we have the PhD students. We have many PhD students starting their thesis only on AI, on the data. And this is a reconstruction of Adriatic Sea wave modeling via an innovative system, graph-based deep learning. And this is the reproduction. You see a little bit of red, but a lot of blue for 1 year, reproduction of what the algorithm has learned from a previous period, right? So we can emulate. Why is it important? Because I can emulate in my coastal area and I can do hazard mapping, right? I can say, where is the hazard? How long did it last? And studying this time series. And it takes me 20 seconds on one GPU. 20 seconds, you know. I've been teaching oceanography now for many years. And you know, it takes years for a student to be able to work this way. And now it is 20 seconds. You know how many thought experiments you can do? Enormous. Okay. And then last but not least, we know we have to protect our coast and we use nature-based solutions. And so we can ask questions now to our models. And we should have AI models to answer this question. This is a question, for example, we answered together with our region on the seagrass belt that we could put in front of the Ravenna area. And we know that we decrease the energy of the waves. Now, is that enough? No. We need to also make the assessment on the economic value and the multi-use of the coast. Okay, so now this is the network. This is the network that from University of Bologna and supported by the Emilia-Romagna region, we are trying to coordinate. We develop prototypes. We are not the only one developing prototypes. We develop also in other places. And then we come together, we compare to see if we can upscale from the local needs. Last but not least, we need to educate early career ocean professional. And fortunately, with this collaboration with Cineca, we are advancing new courses for coastal resilience for early career professionals. So overall, I'm going to leave you with three of my thoughts. And the first one is, we have the UN Ocean Decade. Please contact us at the center, the Decade Collaborative Center, if you need help. Is trying to shape the next generation of science for coastal risk assessment and management. Don't try to do it all together. Please come and, you know, we will find the right framework maybe for you. Innovation is driven by advances in cloud-based data system, next generation coastal observing networks. We need observations, right? We need observation. We cannot do only with models. And AI-powered forecasting models, 20 seconds, half a second. And the DCC-CR of the Emilia-Romagna region and the University of Bologna are working to transform local solutions in globally scalable approaches, and we will be happy to hear you and do it with you. Thank you very much.
Thank you, Professor Pinardi.